where's the school that uses helicopters in the classroom?
What family owns its own private oil company?
How did the feminist movement put this company in business?
What engineer has to clear his own right-of-way?
Industry on Parade, a brand new look at our America. Produced
Informed than their counterparts anywhere else in the world. Industry is constantly improving employee-employer understanding through face-to-face contacts, employee opinion polls, company publications, bulletin boards, and in-plant meetings. Each year, thousands of employees contribute to the suggestion system set up by management. Such a free and steady flow of facts and opinions both to and from employees helps bring about better understanding, cooperation, and harmony in working relationships.
Industry on Parade calls on the Vickers family of Wichita, Kansas. It's not just a social call, for this really isn't the Vickers home anymore, but it is headquarters for the family business presided over by Jack Vickers, Jr., whose dad founded the one-man oil company back in 1918. Here's the first well Jack Sr. brought in, still producing a few barrels of crude a day, though the drill shed, derrick, and other gear are mostly made of wood, and there are such makeshifts as a balance for the pumping arm that's nothing more than a box full of rusty nuts and bolts. Since Dad brought in this one, the company sunk hundreds of wells, and more than 250 of them are producing. But the organization is still wholly owned by the family. Jack Sr. is gone now, but his wife and children go right on risking capital on new holes, as he did, and proving again that this is a country in which you can remain independent and still make good. From wells in production, the crude oil is pumped into a pipeline system leading to a refinery that was pretty skimpy at first, even though it did take most of the family's income during the first few years after they got into this oil business. Nothing skimpy about it now, though. It's about as up-to-date as any to be found. They had to build a refinery because there weren't any around then, and oil was too expensive to ship in its unrefined state. This same isolation also confined their sales for a long time to the surrounding area. But now pipelines, tank cars, and tank trucks carry 12,000 barrels of their products a day into half a dozen other Midwestern states. At the main office, Mrs. Vickers Sr. still takes a very active part in direction of the company's affairs, at a desk upon which a portrait of her late husband looks down, probably with pleasure at the way his family venture's been kept going. In addition to being company headquarters, the old family home and grounds are also a recreation spot for the firm's 250 staff members, who rightly consider themselves part of the Vickers family, too. And a pretty good family it is.
Industry on Parade calls on some masters of the cutlery craft in Newark, New Jersey. In the instrument manufacturing industry, techniques can be traced back to 17th century Germany. But those techniques have developed and improved in our atmosphere of freedom and competition, so that today they are applied not just to forceps for surgeons and other equally specialized, equally expensive tools, but also to such familiar articles as manicure instruments, like these lacrosse nail scissors being fabricated here at Schneffel Brothers Corporation. Let's watch just a few of the dozens of operations involved in making an apparently simple pair of tweezers. First, the high-carbon steel is cold forged on the percussion press. The blanks now must go through the flashing process, that is, have the excess metal trimmed off. Here's a machine they didn't have back in Germany. Nor did they have welding devices like this to join the two halves of the tweezer together. After being heat-treated, the instruments are nickel-plated. This is to prevent the corrosion that strong, resilient, high-carbon steel is subject to. The company started in business around the turn of the century, but found no real demand for manicure equipment until women began flowing into offices and factories. Then, not only women, but men too began to pay attention to the condition of their hands. The plated tweezers now are placed in a holder on which they will be buffed to a high polish. And there they are, ready to be mounted on cards for display in drugstores. And next time we see them there, we'll realize that not only craftsmanship of the highest order combined with modern mass production methods has made them universally available.
Productivity is one of the keystones of American progress. Productivity is the end result of men in good health, working with modern machinery in good repair, operated by management of goodwill. Men, machines, and management are employed by the savings of people invested in a machine shop, store, farm, or factory. Productivity is greatest when management is able, and both employees and investors are well paid for their investments of time and savings. Increased productivity helps reduce costs and prices, increases wages and salaries, and enables all of us to enjoy higher living standards.
One of the very last of the remaining narrow-gauge railways in the country takes to the highway, but not for long, only long enough to get it to its new, permanent location in the Shenandoah Valley of Virginia, at the foot of Massanutten Peak. On a mile of track, painfully hauled in and laid, rail by rail, a group of railroad enthusiasts, duplicating in miniature the work that went into the great lines that spanned the nation, have transplanted a locomotive and two passenger cars that used to run through the grandfather mountain country of North Carolina and Tennessee. From 1866 to 1950, the Tweetsy train, as the mountain people lovingly called it, ran over the tracks of the East Tennessee and Western North Carolina Railroad. Then progress caught up with it, and it was retired. Until a Harrisonburg doctor named Paul Hill organized a group to buy it and put it back in service here. As a hobby, to help children enjoy his greatest childhood pleasure, and just because he and the others dreaded to see the disappearance in America of the narrow-gauge railroad that helped open up many parts of our nation. With wives and children watching and the three originators of the idea supervising, many an evening, weekend and holiday was spent learning how much goes into building and running a railroad. Many rail fans sent in contributions to help meet the huge costs of laying even 1 mile of track. The Southern Railway contributed equipment. The Norfolk and Western sent along ballasting for the rails, and other companies also lent a hand. But the work, well, the men of the Shenandoah Central Railroad had to do that themselves. The only engineer in the country who has to clear his own right-of-way, and the only railroad bugs who know the feel of blisters caused by laying down ballast. But at last, the happy day arrives, and we're all set for our first ride on the transplanted Tweetsy. The conductor gives the highball, and away we go. Supplying water for the boiler is no great problem. Cub Run is full of water. This is the train which, when it was still running down in Tennessee and North Carolina, was the subject of a book by Archie Robertson called Slow Train to Yesterday. It's the hope of those connected with this nostalgic venture that now the Tweetsy can be the subject of a sequel, Slow Train to Tomorrow.
How is this girl improving public health and safety?
What 2,000-ton press helps water your lawn?
Who makes an automobile that can take to the air?
What primitive instruments are these children using?
Industry on Parade, a brand new look at our America, produced on film each week by the National Association of Manufacturers. At Newark, Delaware, Industry on Parade visits the $2 million home of a department of the DuPont Company, a department that produces nothing and sells nothing. The major concern of this branch of the firm is health and safety, the health and safety of employees and of customers who buy or use the company's products. Here in the Haskell Laboratory for Toxicology and Industrial Medicine, tests of all kinds go on endlessly. For example, this test is designed to find out exactly how much energy is consumed in performing various workloads. The workload is determined by the amount of friction on the rear wheel. What the man puts out from second to second is indicated by his blood pressure, oxygen consumption, chest expansion, and other factors. Also used in the long-range program to learn how industrial workers can avoid undue fatigue is the LaRue platform, a device mounted on quartz crystals which record every change of pressure on the platform and permit close analysis of the movements of a person standing on it. To prevent injury or illness from chemicals or manufacturing processes, rats and guinea pigs are exposed to an atmosphere in which the gas, liquid or solid understudy, is suspended. Despite the gas mask, the atmospheres pumped into the bell jar are rarely outright poisonous, although any substance, even salt or baking soda, can be toxic if taken in too great a dose. That's what they're trying to find out. How much is too much? The effects of chemicals on the body can vary under extremes of temperature and humidity. So here, those factors are introduced. In the course of their studies, the researchers have come up with a superior type of one-layer Arctic clothing. Another byproduct of industrial integrity that prompts companies to go far beyond the requirements of law in protecting the public health and comfort.
America's new frontiers are pushed back every day somewhere in this country through research. Each year, industry spends $2.5 billion in research to discover new products or improve those already on the market. These new and improved products mean better and less expensive things for all of us, but more important, they mean more and better jobs with an ever greater chance for better living for everybody. This can happen only in America, where industry is free to experiment, where men know they can refuse to accept limitation, where we have a competitive enterprise system in which nothing is impossible.
The green at Waterbury, Connecticut. Sprinklers that keep this and other city lawns green all summer were contributed by one of the town's leading industries. Needless to say, sprinklers are among the products made by the contributing firm, Scoville Manufacturing Company. A sprinkler is a little thing, but making it involves some mighty big operations, like the extrusion of rods in this 2,000-ton hydraulic press. As pressure mounts past the 3,500 pound mark, the metal squirts out like toothpaste and is taken up on reels. At this point, the metal is still red hot, so the job of moving it out of the way is handled by machine. The rod, cut to lengths just a couple of inches long, will be used for making sprinkler heads for one of the latest models in the firm's green spot line. Serrations will be cut in the metal and holes drilled in the serrations to throw water evenly over every inch of the area to be sprinkled. Elsewhere in the big plant, other parts are fabricated and assembled, like couplers. A sprinkler used to be an extremely simple gadget, but it has grown more complex as a result of increased demands made on it. You'd be amazed at the amount of engineering that has gone into this little device. The big gear is an impeller gear. Water striking it causes the sprinkler heads to swing back and forth in uniform sweeps. The second sprinkler head is installed. The parts all have been so accurately machined that they fit together as neatly as a Chinese puzzle. We've been using the word sprinkler pretty steadily here, but actually the Scoville people wish the public would adopt a better word. For, they point out, a lawn shouldn't be merely sprinkled, it should be soaked. A light sprinkling can be damaging. Now goes on one of those modern improvements we mentioned, a control dial that regulates exactly the distance the spray is thrown. There's an abundance of gaskets and packing to keep the unit watertight permanently, so the water will go where it's supposed to and not form a small lake right around it. The two halves are secured together, and the product is complete except for the addition of a base. Another interesting fact about lawn watering we picked up here in Waterbury is that, contrary to general opinion, the best time to water a lawn is not in the evening, but in the early morning hours. Excessive moisture during the night, they say, can cause brown patch and other fungus diseases. Live and learn. No matter what time it may be, though, here's one family that isn't going to wait for early morning to try out their new lawn sprinkler. They're really well equipped, with attachments for every special purpose. Don't watch it too long, folks. You'll be hypnotized.
Three Longview, Washington industrialists with a dream of the future. A future in which motorists can break through the 40-mile-an-hour speed barrier prevailing on the nation's highways by taking their cars above the highways, up into the sky. On the ground, the Aerocar, as they call it, can drive freely like any other automobile, or it can tow the wing and tail sections behind it. To take off, merely swing the wings in place, turn a few handles, and you're ready to go. We called it a dream of the future, but actually the Aerocar is already in production and may be seen in use on the streets and in the air. As an automobile, its appearance is rather unusual, but as an airplane, it looks pretty much like conventional models. The vehicles are turned out here at the company's plant in Longview. Handmade units produced so far have been mostly for demonstration purposes to build a backlog of orders that will permit assembly line operations and bring down costs. Now let's take one of the flying automobiles up and see how it performs in the wild blue yonder. The changeover involves about as much work as changing a tire. The wingspan is 34 feet, and as an airplane, the craft is 21 feet long. Gross flying weight is 1,900 pounds, of which about 400 pounds is payload. So now we're all set. The changeover took about 4 minutes. Moulton Taylor, who designed the Aerocar, is going to be our pilot on this flight of what he is firmly convinced is the car of the future. The pusher-type propeller is powered by a 135 horsepower engine that will get the craft up to 110 miles an hour or better. It cruises at a little more than 100. A few minutes ago, it was an automobile winding through traffic. Now it soars over lakes, mountains, and cities. Maybe Taylor has something with his talk about the car of the future. One thing is certain, you aren't stopped by many red lights up here.
In the past, as America's population has grown, its natural resources developed. New industries came into being. More and more people invested their savings in plant, tools, and machines. This, in turn, permitted employees in industrial plants to increase their output through the use of mechanical power, newer and faster machines, as well as better production techniques. When the assembly line was introduced, it brought with it better testing and inspecting methods. These not only permitted the employees to increase their output, but enabled them to improve the quality of goods they turned out, and their wages and standard of living continued to climb.
The New England Conservatory of Music in Boston, one of the great music schools of the country, heavily supported since its founding 87 years ago by leading industrialists of the Northeast. Here, young people gather from all parts of the country to become indoctrinated in the creation of fine music and the recreation of the music of masters like Beethoven, whose statue looks down upon them as they pass to and from classes. Harrison Keller, president of the conservatory, recounts some of its history. At the start of his studies here, a student plays a number of instruments, eventually concentrating on the one he himself selects. He learns to play with other instrumentalists and often to write his own pieces. The very young are encouraged to experiment, at home usually, with the making of their own instruments. This increases their general musical understanding, acquainting them with the basic ways in which musical sounds are produced. The instruments they come up with, like the triangle, formed from the length of curtain rod, or the drum, fashioned out of a tin can and 2 pieces of inner tube, bear a strong resemblance to primitive musical instruments in use all over the world. A pie plate and a few bottle caps make a tambourine, while a handful of marbles in a gourd become a Mexican rattle. Soon as we get the musical tumblers in proper tune, we'll sit back and listen to what these instruments all sound like in the hands of their young creators. Keeping all factors in mind, we're sure you won't expect to hear the Boston Symphony.
Diners out, enjoying a dessert of Fruit Supreme. Fruit Supreme from a can, we might add. Perhaps from this warehouse of a member firm of the Canners League of California. And here, working away all by himself, is an agent of the Canners League who has selected 2 cans of fruit at random. While one of the cans, unlabeled and bearing only a code number, goes to a laboratory for analysis, The other ends up in San Francisco at an annual shindig called the Fruit and Vegetable Sample Cuttings. Samples from the warehouses of all the companies in the league are displayed on a series of long tables in trays marked with code numbers corresponding to those on the cans. Only a few officials of the organization know what brand each code number represents, and care is taken to make sure cans are emptied into the right trays. For 2 days, all the wide variety of fruits and vegetables produced in California will be judged by experts. Here are peaches. Now, almost any producer could come up with a single can of perfect peaches, but these, you'll recall, were selected at random. And so the beautiful fruit spread out here is just run-of-the-mill, what any shopper expects to pull off her grocer's shelf, and does. The judges nibble, probe, and study the fruit carefully. The tiniest blemish means loss of points. Results are not made public. Each company learns only how its own samples were rated. And though there's no publicity, high-scoring companies are plenty proud, while all the canners find the event an added incentive in their striving to make any fruit we eat fruit supreme.
Industry on Parade visits a Detroit machine tool firm, the Cross Company, to learn about a method for wringing still greater production out of massive instruments like this. What you see is a machine tool. The wonder child of modern industry, it can perform all sorts of precision jobs automatically. It mills, drills, reams, taps, spot faces, and counterbores right down to the specified thousandth of an inch. Only limitation on this fabulous machine is the time it must lie idle while its worn tool components are being replaced. When the number of tools incorporated in this one machine is somewhere up in the hundreds, it can spend more time lying idle than it does in operation. And one more complication lies in the fact that since some of the tools work harder than others, they don't all wear out simultaneously, but one or two at a time. Another aspect of the problem is that if you wait until a tool is completely gone, toward the end it will turn out bad work. But one possible answer to all this may lie in something called a toolometer, a control unit that keeps track of the hours and minutes of work put in by every tool in the machine and keeps replacement tools handy. The back of the toolometer is a maze of electronic equipment that connects with all the machines on a line and automatically stops the proper one when indicators reveal one of its tools has reached the end of its work life. As we watch, time runs out for some tool. The switch is thrown and the machine stops. The setup man who replaces worn parts learns instantly from the indicators what tool must be pulled out. For our benefit, he demonstrates how the replacement tool has been preset to fit into the machine with no further adjustment. With the presetting done in advance, this is another step that no longer adds to the costly seconds the machine is shut down. The dial is turned back to the start mark, and before you know it, the machine will be humming once more. The worn tool, if it merely needs resharpening, will be ground and then take its place as a standby. And thus the wheels of industry are kept turning. The wheels that turn the tools that make the machines that spell a better life for all of us.
Thanks to reforestation and conservation, there is enough saw timber standing in the nation's forests to build a 6-room house for every man, woman, and child in this country with lumber left over. This is true despite the fact that during the past 350 years, twice as much wood has been removed from America's forests as was grown when the first English settlers arrived. Today, each new wood growth of all sizes equals 98% of the amount removed and destroyed by fire, insects, and disease. Forests of the United States can continue to fill domestic requirements and provide wood for export.
Ever see a farmyard as happy as this one? They have good reason to be happy, for no toy enjoys greater perennial popularity than the little rubber figure that squeals when it's pressed. Such figures are turned out by the thousands each year at companies like Rempel Manufacturing Incorporated of Akron, Ohio, and still the demand continues to grow. Here, a herd of rubber horses come out of the mold. The toys are made of a water-soluble latex which we see being poured into the molds. The molds are of plaster which will absorb the water in the latex solution as the molds, clamped together half a dozen at a time, slowly revolve. The rotation also distributes the drying latex in an even layer around the inside of each mold. Removed from the molds and cured in a low-temperature oven, the toys now are ready for extensive finishing that will transform them from what seem to be shapeless blobs of rubber into little animals and people with distinctive characters all their own. First step in the finishing will be trimming off the excess rubber around the edges. They buff the toy smooth, leaving not a trace of the rind, as it's called. And now that distinctive character we spoke of really begins to develop. Here in the paint department, where the toy moves along from one painter to the next, and each girl masks off all but the features that will get one certain color of paint. Color for the little cowboy's hat is now sprayed on. Does your doll feel dull and listless, weary and woebegone? Well, here's the treatment that will put a sparkle back in his eye. This tiny gentleman is currently one of the favorites in a line that adds new members every year. All of them the creation of the company's founder, D.G. Rempel, a man who fled Soviet Russia 30 years ago to build a life of his own in a free society. Build it he did, and in the process, he started a flourishing business that has brought happiness to many thousands of children in his adopted homeland.
Fewer accidents are taking place in industry than ever before in history. It's a fact. Employees are safer on the job than off the job. Fewer accidents are the result of industry's effective accident prevention work in providing safe, healthful working conditions, safe tools, safe machines, and safe work methods. And employers all over the country continue to adopt sound, progressive safety practices and enlist employee cooperation to do their share in cutting down on industrial accidents.
We're in Racine, Wisconsin to watch a search for hidden treasure. Not buried pirate's gold, but treasure that's in plain sight everywhere in town. The men who set out to find this wealth are salesmen from a number of steel companies who reverse their usual routine and try to find steel their firms can buy back. Scrap steel, currently one of our most precious metals. The salesmen fan out to every firm in the county to point out to company officials sources of steel they may have overlooked. Obsolete or worn-out machinery can become useful machinery once more. Member companies of the Manufacturers Association of Racine, who would themselves feel the pinch of a steel shortage, helped arrange this intensive one-day drive. The objective, not only to uncover scrap now on hand, but to impress industry with the need for continuous review of steel on hand that's unusable in its present form. Management is persuaded to go over its inventories with a view toward weeding out equipment serving no useful purpose, and also to intensify efforts in the recovery of waste. At a time when the steel industry's stockpile of scrap is barely enough to last for a few days, not even the shavings from a lathe can be overlooked. Nor the old stove from the cafeteria. The drive brings forth tremendous quantities of iron and steel, giving impetus to plans to stage campaigns in 2,000 other communities across the nation. The discarded metals go first to scrap yards like this, where they are sorted according to the type of furnace in which they can be used: blast, open hearth, electric, and so on. The small stuff must be baled so it will melt instead of burning. Scrap is not used in steel production merely as a matter of economy. Scrap is an essential ingredient, and some of the better grades of steel come nearly 100% from scrap. The steel needs of industry in meeting heavy defense and civilian production schedules make it imperative that the rest of the nation follow the example of Racine, Wisconsin.
With our country fighting on two fronts, against aggression abroad and against inflation at home, efficient and economical government has become more vital than ever before. We need a streamlined governmental setup that can react speedily and effectively to any emergency. We need to cut out all waste of manpower and materials so that our economy can produce enough for both military and civilian requirements. We need to reduce the inflationary pressures of government spending and make the utmost out of every tax dollar in goods and services. For these reasons, better organized government at lower cost is the keystone of a real defense program.
The Commercial Metals Company plant in Houston, Texas, where daily thousands of tons of iron, steel, brass, aluminum, and other metals arrive in this condition. It's scrap metal, cuttings, filings, and other waste from factories, shops, and homes. Of what value is it? It's of tremendous value, not merely in terms of dollars and cents alone, but in terms of providing the raw materials now so urgently needed for nearly any product you can mention, especially the ships, guns, and planes required for our defense program. Here's another kind of scrap: short ends from sections of pipe used in building the big and little inch pipelines. The powerful electromagnet transfers them to the proper pile. Power shears cut the pieces of pipe to the size suitable for the steel furnace for which they are destined. Just about all the scrap arriving here at Commercial Metals must be processed in one way or another before it can be sent to the mills, where it will be melted down and refashioned into useful articles once again. The thin steel of this junked automobile body, for example, if dumped into a furnace as is, would burn up like a sheet of paper. So it goes into a hydraulic press. Now let's see what 2,500 pounds of pressure per square inch can do. That 1,000-pound block of steel was an automobile. Inside the plant, still other sorting and processing is in progress. Shavings from a lathe may end up on the same pile with discarded kitchen utensils. All must be reduced to a size and density that will permit easy shipping and resmelting. Ferrous and non-ferrous metals are separated by magnets. Those that contain no iron drop off the belt, while the ferrous metals are retained until they pass out of the magnetic field. Some precious and semi-precious metals also come in, and even the mercury from a discarded thermometer is saved here to go back into the stockpile of vital materials. This is conservation of our precious natural resources on a day-by-day working basis.
America's new frontiers are in science. Today's pioneers are found in the research laboratories of industry. Engineers and scientists are constantly searching for new discoveries which will benefit mankind and help raise living standards. There are 120,000 scientists in the nation's 2,300 industrial research laboratories, and more people trained in science are needed. It's estimated that 40,000 engineers are going to be needed every year just to meet our minimum requirements. So when choosing a career, consider the field of science.
At Kingsport, Tennessee, the sylvan atmosphere suggested by ivy-covered walls fails to disguise the fact that these gentlemen preside over a very busy, highly varied book printing operation that's representative of the best traditions of modern American publishing. But here at Kingsport Press Incorporated, the ivy on those walls outside does correctly symbolize the closeness to the soil of many people in the organization. For the great majority of employees, even those in the most highly skilled categories, trace their ancestry back for generations in this section of the Cumberland Mountains. And with the active cooperation of management, they've developed a mode of living that allows them to enjoy the fruits of industrial employment and the satisfactions of living on and working the land on which they grew up. Masters of the demanding graphic arts during the middle hours of the day, farmers early in the morning and late in the afternoon. A little earlier, we saw Eb Norris at work as an oiler. Here we see him feeding his livestock. And Clyde Smith prepares to let his livestock feed him. One of the women we watched sewing bindings back at the plant was Nell Fletcher, who takes about the same pride in the fine books she helps produce as she does in her fine Black Angus calves. It's not a matter of holding two jobs at once, but one of happily combining industrial progress with a way of life their families have followed since Daniel Boone opened up this part of the country.